All right. It's my great pleasure to introduce Andrew Neal, who's a GIS technician with Facilities and Information and Technology Services here at The Ohio State University. He has a master's degree in environmental sciences and management, which is how he got into GIS. He's only been here at OSU for a year, but it's been pretty amazing to see what these guys have done. GIS has historically been a flexible consumer of many different types of data. With the increasing use of web APIs, this is even more the case. Campuses may take advantage of this data flexibility to combine applications that may have traditionally been thought of as data silos. We present some of the applications used on campus at The Ohio State University. And I have to say I signed up for this because I saw a webinar that OSU put on a couple of years ago, and I was quite frustrated because I've been at this for 10 years and I haven't gotten nearly as far at UMass Amherst as what these guys have done in the last 5 years. So my hat's off to you guys here.
Cool. Thanks so much. All right, can everybody hear okay? Good. Welcome to Columbus. Thanks for coming. How many people in the audience are just GIS technicians or analysts or programmers? Okay. A lot of you. Good. Very good. All right, I hope I do this justice. This presentation, I'll just start off by saying this is the precursors that Sean Fontanella is our GIS programmer here, also hired about a year. Hired on to really kind of develop some apps and some programming for our GIS database that has been built up over the years. He kind of made this presentation, and there's some technical stuff in here that I'm not fully comprehensible on. So please save your technical questions. Come see me afterwards if you have some really technical stuff, and we can get you in contact with him later. So bending the data silos, trends in spatial GIS. I think what we're really talking about here is Sean wanted me to show this. This is kind of some of the technology that will be coming out in the future that is really groundbreaking. This is browser-based, web browser-based, and on the left side we have Esri 3D mapping, and on the right side we have a BIM model, basically a Revit model. And those are both in a browser, and they're linked together. So you can select this bridge, and then you can come on this side and spin it around and do all this really cool stuff. Imagine that on your campus with buildings or any other structures that you have, or your rows or anything. So this is kind of where things are going. And there's a couple key things that make this possible and make this accessible. So the biggest thing that I have learned from this presentation is that that this stuff is accessible through web application programming interface, APIs, web APIs. So what this means is it's spatial. The data is delivered in a format that can be plotted and mapped. It's on the web. It's delivered using these HTTP, HTTPS stuff. It easily gets through firewalls. And the API means, I'm sorry, I'm reading from the slide here, but it allows programmatic access to Revit files, shape files, geodatabases, all sorts of other types of files and systems and databases. So some examples, we have our ArcGIS server REST API. Google Maps uses this web API. Revit servers. All of these things use this API format. And this example here kind of basically shows that what we do is we pull in data from one source, we use a web API, and then we can visualize and map this stuff and plot it. So this map here that you're seeing, I'm going to get into this just a little bit to explain some examples here. This is a bike share map for Columbus. So these are, everyone has bike shares in their cities now. These are COGO stations. You go to these stations, you rent a bike. This service is open data, basically. It's published. You can pull this in. And in the old days, this would not be like this, right? Maybe you had to download a tile, or you had to go through a list of data or something like that. Now we can pull it in, and these things are what we call, these are JSON objects, GeoJSON objects that are overlaid onto a map. We have a base map, we have features, we can pull in other data and show it on top of this. And this kind of exemplifies this web API type of format. So all of these pins have attributes behind them, right? Just like your shape files and everything else. You have available bytes 10, available docs 9, and that's real time. So you can pull this into your map and just show it real time and give your users new information and up-to-date information and reliable information that they can use. So let's get into this a little bit more. This is what's behind that. This is the API stuff. It's tons of information, right? And it's basically code. As we zoom in even further, though, we can break it down and actually see this kind of starts to make sense when we get into it. It's basically just like your attribute table or your fields in your database. And this is a common format that these APIs can then bring in any type of data and show it onto the map just like that. So again, we can just see here that we have our available docs code language 8, and it shows up over here as 8. And we can program this to do lots of different things, and it takes a lot of work to do this, and knowledge of coding and programming. But one of the great things about this is that we have these resources out there like GitHub and GeoNet, that there's a lot of sharing of this information in these codes out there. So I'm not going to say you can just go out and make this map right off the bat, but that's why we are lucky that we have resources and we have a new GIS programmer here in our office. But this is something that you can start to play around with and start to maybe just pull one thing into your base map, into your map. Maybe just start with a bike share for your campus users. So let's go a little bit further here. This is an example of pulling in a couple spatial web APIs into one map. Again, just a different view, but we have our Kogo bike stations there. We have information about them on the left side here. And then you can actually program another one in there to go out to Google Street View and pull in a Street View map of that, so you can see exactly where that bike share is. Maybe you don't like that location because something's going on there. The location of town. Or you just want to know exactly what corner you need to walk to. This is something that you can write a script to have multiple APIs to pull in this other data from all types of sources, and really add a lot to your maps. This information is out there, right? So what we're doing is we're just giving people and users more and more things to make their experience better. And again, these things are in real time. I mean, Street View pictures are taken in the past, but we can then design these pop-ups to have the real-time information with the Street View and links out to directions and things like that. So this is a conceptual diagram of how some of this works. And this kind of epitomizes the broadcasting network here. We have lots of sources of data out there. For us, right, we have the city of Columbus, and we have a Mid-Ohio Regional Planning Corporation that has a lot of data for our area. We have federal data sets that we can pull on. And what we do with some of our stuff, and what is the common case, is you'll have an automated Python script or some kind of script that's going to go out and pull that data periodically or whenever you want, and kind of update that and then send that into your database. We also have static data that we're pulling on from our own databases and our own servers. And all of those things can then be pulled in to an application. And I'm going to show you a quick little application that is not from our team, but it is from OSU. This is what is called the Columbus Urban and Regional Information Observatory, and my colleague Sean Fontanella helped build this for a lab that's on campus called the Center for Urban and Regional Analysis, CURA. And this is kind of what we call like a dashboard, I guess you would say. And you can just see all the types of data that this is pulling in. This is really cool. This is kind of like a snapshot of what's going on in Columbus. We can pull in on our OpenStreetMap. We have our Kogo stations there, and again, it's just a different view of this, right? It's not a map view, it's a tabular view, but we can see the bikes versus the docks. We have census data that we can pull in, and these are all interactable, so we can change what we're looking at there. We're pulling on Twitter, EPA. We have street cameras that we can tap into. There's Google. There's our bus system is called CODA. So we can pull all of these things and throw them into a map, and it doesn't have to be a map, right? It can be graphs. It can be pop-ups. It can be all sorts of data that is easily accessible to people. So this is kind of where things are going. How do we link all of this great data that's out there? And then what does that mean for our campus, for our spatial campus users, for our universities? For us, it really means we have our GIS, we have BIM models, we have space management data, and then we have all sorts of other users that have data stored away somewhere that could be usable by people. So what we want to do is kind of use our actually GIS to link into all of these things, combine them into applications that help us manage our systems better. I lost my little mouse here. So along with that, I mean, you've heard OSU is a really big organization. We have lots of departments. We work with a lot of people on campus, in our administrative office, We work with a lot of people in our academics office, and we also have a lot of external users that are pinging us for data all the time. So, you know, it's key for us to try to work with multiple systems to get these people the information that they need. And then also, as we build stuff out, new users just keep coming on and wanting more information and more applications to come out. And I just want to mention that one of the greatest things when you're building this stuff is to have reliable data as the backbone. So for us, we were able to have this great GIS maps backbone that we've built over the years. This is our base map. If anyone has a chance, I would just advise you to go check out gismaps.osu.edu, play around a little bit. This is our everything but the kitchen sink app, and we have tons of layers in here. We have our landscapes, we have our buildings, and each of these has lots of attributes with it, lots of information with it. This is the building blocks of your mapping in the future in your applications that you can build. Now I'm going to get into a few examples of spin-offs from that, some applications that we're building. That was the everything but the kitchen sink app. Now we're getting into some really focused applications to help specific things. Our first example is a utility shut-off valve collector app. We basically call this the valve collector app right now, and Sean has been implemental in building this. The current state was that people wanted to know where our water valves are inside our buildings. The utility people are going in there, and they never had a real good system of knowing exactly where all these valves were and mapping them all out. You know, the knowledge is stored in people's minds. I'm sure you all have dealt with that. It's just the way things have been done in the past. And there was no pictures or, you know, for hidden valves or buried valves. So we want to make a map of this stuff. We want it to be multi-platform, to have mobile and desktop applications, so you can check it in your office or your field workers can go out and use it. We want to have some pictures so we can easily find those valves and mark up anything on them. And then also we want to pre-populate as much stuff as we can in the field so that our workers are not out there typing away on iPads, which can be tough. So right off the bat, you know, we're GIS people, we're a GIS team. We try Collector, and Collector has its limitations, right? It's really just for some simple collection in the field, and there's not much customization to it. So some of the things we encountered with this is we wanted to be able to filter by floor of our building. We wanted to pre-populate a lot more stuff than Collector was allowing us. The keyboard issue is always a problem for workers in the field. And then also, we wanted to be able to work on our desktops as well. So we're able to customize this out. And again, this is where we were lucky that we were able to have a GIS programmer on our team to do some real customization and coding. But this is kind of our first version of a finished product. Here we can filter by floor. So we have our floor plans in our GIS, linked to our GIS. And you can pull down any floor you want, and that floor plan will show up basically. It's then going to pre-populate a lot of stuff when you go and choose one of these types of valves and put it in the location. Many things are pre-populated. This was very easy to use and very easy to train people on. It took about 20 minutes, I'm hearing, and a lot of our workers did use iPads in the past, so this was pretty straightforward to them. The symbols made sense. Put it on the map. A lot of things were pre-populated. They were able to then add in pictures and mark them up. We didn't even know that they were going to be doing that, but they were able to then mark things up on the pictures, and those are attached into that database. And this is all backed up into a GIS. So this data is now a feature class, I guess you would call it, in a database with a bunch of attributes. So this really allows us to do a lot more. This allowed us to give a customized solution to these guys that were looking for, that had a problem. And it's going to lead to a better management of those valves. Another example that is in progress right now is a facilities condition app that we're trying to build out. Again, Sean is taking the lead on this one. Again, we're just seeing these problems arise where this is another situation where we go out and get the conditions of buildings every few years. I think every year there's a certain number of buildings that we get conditions for. I'm sure all of you do similar things. This was a system where there were no maps, there were no photos. There wasn't really a good history of our building records. The database was kind of a mess. It was PC-based. There was no mobile option, so surveyors were going out with paper in the field. And so we want to make this better. We want to see how we can use GIS in our application building to improve this and make it mobile, link it to our GIS so we have a history of these conditions tracking, and also have secure authentication so people are going in there and the right people are making these surveys, not making edits to these things. This is in production right now, and I'll mention, Sean wanted me to mention that he's using a coding language called Xamarin, which allows for Android, iOS, Windows apps. It's a native language on all of those devices, so you write the code once, and then it can be used on all of those devices. And the good thing here is that as we're building out these apps, and we have someone to build out this code for us. After that, a lot of these things are copy and paste, and then just edit a few pieces of code to reach out to a different feature class or reach out to a different database. So once you kind of build some of these apps and start building some of this stuff, these web APIs to do this stuff, that will be the hardest part, is getting over that first hurdle. And I say this like a non-programmer, so. Now I just want to show, this is something I've worked on. Out-of-the-box apps are also really good. If you have time, I'm sure some of you already delve into this world, but we've been collecting tree data for a long time, and all of this was done in the field. Again, paper maps, printing off aerial imagery, and people going out in the field and documenting what was there. And then it did get into a GIS database at the end, but it was more work. We're going out and collecting stuff on paper and then entering it back in the office in a database. And we wanted to track stuff better, how condition is changing, how size is changing, are our trees growing well, do we need to plant different trees? So this was something where Collector worked fine for that part. And this is just a really simple app where we were able to, you make a web app and you publish it into Collector, and you can go out and you tap on a tree and tree information pops up, and then you can edit that tree. We were able to use domains. I mean, I'm sure all of you are familiar with this kind of stuff, but domains helped a big time with genus and species, so people aren't typing in these crazy things. And in the old database, when we didn't have domains, you had thousands of records because one spelling error makes a tree species different than another one. So, so those are all little things that can really help. And then this also allowed us to have associated and related tables to this stuff. And that adds a whole nother dynamic that you can have all sorts of other information in tables related to those trees based on a common ID. So now we have things that are tree maintenance records. We can have tree benefits, how much ecosystem service benefits a tree is giving. That can be its own little table, but it's related to that one asset, that one tree. But this also, this didn't go far enough for some of our users. And as the landscape maintenance crew found out about that Collector app, they were looking for some more stuff. They wanted to go in and actually be able to filter, to be able to search for certain specific trees, and the Collector app just doesn't let you do that. So we were able to do the web app builder in ArcGIS. Again, it's out of the box, but it's really powerful. And those things, you can customize those too if you want later on. But if anyone hasn't done this, you go in, you make a web map, then you hit publish into an app. And you can choose from tons of widgets, and these widgets are pretty powerful. There's a lot of really cool tools in there. And some of the simple tools are the most powerful ones, such as filtering by tree species in this case, or searching for memorial trees. People are looking for where are all our memorial trees on campus. So this has been really good too. And I'll show you a couple more features of this since I made it. What this also did was allow you to have your attribute table right here. And this is also powerful because another group on campus, our Chadwick Arboretum, we have a small arboretum here as well, they had kind of lost touch with their ARC mapping skills. So this allows them to go into a web browser and see the attribute table and see that stuff and edit that stuff. And that wouldn't be possible otherwise. So this is cool because you can share it on the web, and these apps too, you can take out in the field on your device and still use it and locate yourself and have your GPS going. So it's really powerful to be able to share a link with someone, and they can open it up in their web browser and start doing stuff. This is kind of the whole shebang of that, and a couple other aspects that we can have here. Those related tables that I've talked about. You can add those in down here, so you can add tables in there, and you can edit just those tables and not the feature itself. We can link to another Esri program called Survey 123. Survey 123 is really form-based, so it's based on Excel and macros, but you can have these really detailed surveys, but it's not, and it's attached to your GIS point, but it's not your GIS data itself. It's not a database. But you can link out in your pop-up box to a Survey 123 survey. You can link out to lots of things. So you can develop these really robust apps that have a lot of functionality or one functionality, depending on what your users want or need. So there's definitely a case for having some coding, some programming, but you can do a lot with also out-of-the-box apps from Esri's products and AGOL Online. Okay, so yeah, all right, that's not too bad. It's a little short, I apologize, but just to come full circle, this is kind of my conclusion slide, and then we can go into questions and comments, so we can have a discussion. Bending the data silos and trends in spatial GIS. You know, we saw all of those users and all of those people have their own systems and their data, and we always think of those as silos, the silos of data, right? Well, now I think that through Web API mapping and through GIS, we can kind of break down those silos. We can bend them, if not break them. That was my tagline here. Pretty good, right? But you know, GIS can kind of bring all of this stuff together, link these information systems together, as well as I'm sure other systems can do this as well. But GIS is a real great tool for this, and it's catching on more and more with people, and more people are using it. So we're able to actually rely on a lot of student work to come in and clean up our base map, which gives us really good data. So if the students are learning it, the next wave of people are going to be using it. So how can we reach out to all of our users and all of our people on campuses and outside of campus and tap into their stuff to make our university a little better and our management a little better? Because you know, at the end of the day, I think we're really in the service industry, right? We're serving the other staff around us. So I'll leave it at that. Take some questions and comments. If you have anything really technical, come on up and see me later, and I can get you Sean's email. So yeah, all right, thank you. Yeah, right there.
Two sides of the question.
Sure.
First is, how do you integrate with your space system? And then maybe as an example, how much, whether you do this with your space system with other systems, how are you feeding information back to your sources?
Sure. I'm going to actually ask if can Larissa handle this maybe? Yeah. Larissa's our enterprise GIS manager. She yeah.
Repeat the question into the mic.
Absolutely, I forgot about that.
Could you go up and speak into the mic for the-
So I think the question was really, you know, how are we integrating our spatial management system into our GIS, and then is that integrating back into our spatial management system at all?
Okay, so we do not feed back into the space data information system. That is, our SIMS is like, it is the data house of record. So we only pull that into the GIS. So if you go to our GIS Maps application, that's what you're gonna see. You're gonna see it's just a data pull. It's nightly, it's static, it's not live. That was just for speed. We did try doing a live query connection, and it was just, it really slowed down the response time, so. No, it's not GIS enabled. It's a database system. I think it's SIMS, right?
Yeah. It's called SIMS. Yeah.
Other questions?
Yeah, I'll probably I'll lean on Larissa a little bit while she's up here. Yeah, there's a couple over here first, I think. Yeah.
Do you ask all your design consultants to provide GIS information when they submit a project? And if so, how is that information transferred into your systems?
It is, no, we do not. We get, sure. The question was, sorry. The question was if we require our project managers or outside people developers to give us their data as GIS data. We get the architectural data. We do not get it in GIS form. We then convert it to GIS form in our systems. We do that internally.
Yeah, we heavily use FME. So all of that data, if you're talking like construction data, project data, design data, that's all either in CAD or Revit now if it's over $4 million.
Yeah,
I'm Jeremy Durst. I
We're
manage
also
the
on.
utilities side of the GIS. Larissa and I are actually in different offices, but we work together all day long. A lot of the outside utility stuff, we collect as it's going in because we're also the campus utility protection service. You know, the call before you dig guys. So a lot of the utility stuff coming in during construction, we grab as it's going in, and then most of it comes in CAD form. And our students then, translate survey data, into GIS.
Yeah, if you're trying to get to the, how do you get it all into GIS? So,
Basically, from an outside source.
right, so standards. If you've gone to any of the other Revit discussions that OSU is putting on, we're very standardized. Both our CAD drawings and our Revit models are all very standardized. So when we run them through FME, or if we're forced to georeference them if they don't come in with spatial data, that transition is actually fairly smooth, but only because they're super standardized.
This is a question sort of about what's public facing, what's internal staff facing, and sort of security issues and things like that. I guess what I'm wondering is sort of in a general policy way, how do you distinguish what gets public facing, what's facing staff, and really one specific part of that is about floor plans and how available are they?
Absolutely.
Sure.
I'm
just gonna repeat the question for the thing. The general question was, how do we deal with our public-facing versus our private-facing GIS, specifically regarding safety issues and security issues and floor plans and things like that.
So yeah, I can talk on that simply because I've been around here forever. So
Great. I'm gonna bring you to all my presentations. Yeah.
So yeah, now if you recall, like the little quick screenshot he showed, just showed basically our base map and our transportation data. There is way more data layers. You would have had to click the little login button thingy, and then we use our shibboleth authentication as to whether they have access to that. But it is not just SHIB that's deciding that. So it's not like, hey, you're a university person, you can access that. We actually have, if a request comes in for specific data, we actually have that approved. Either utilities, Jeremy's group will decide, yes, this person or outside contractor will have to get them a guest account is what we do for outside contractors. We provide them a guest account, and then we have multiple levels of access. So they can either access just utilities, or they can have access to our real estate data, which also includes a lot of costs and numbers that we don't really share publicly. Public safety data. So if you're a public safety user, then you also have access to a lot of those blue light phone data. Parts of the blue light phone data are publicly available, and then even more parts are secured. So we have that all in a separate database table. So when they log into SHIB, then it's secondly authorized through our SQL database. It says, okay, now you made it through SHIB. Which table, which group are you now allowed to see? And then it'll display those different data layers, which I could do a demo later. But floor plans, again, same thing. The space management people allow, like Megan actually manages our space data. Yeah, Reggie.
Archive records, I'm Reggie, so I manage archive records. So all the record plans for all the buildings, I give them access to, whether it's what maintenance. So currently there's like 168 they have access, but they have current projects on campus.
Do you
So
show,
it's not like public cannot access.
do you show your floor plans to the public in any way at all?
Not at all.
You could request that information if you had specific needs for that, right? If you show you're working on a specific OSU project. Sometimes we allow that for a lot of master's students that are doing particular projects. You can, if there's a valid reason for that, you would have to get a guest account. But yeah, we'll have our our space data, those floor plans that you saw on the Valve Collector app. That's also available through our regular GIS Maps application. It's on the login side.
And as far as the record documents, now that it's in the SIMS application, I can track everything. So I know everything. I know who's downloading what drawing. So if we have an aide working on the Med Center, they really shouldn't be downloading like the Shots Center stadium files. So it tracks everything.
Other questions? Yeah, that's, for us, our biggest, it's been booming this year. We threw out a couple, and now everyone and their brother wants their own collector app, which has been great for us because it's allowing us to crowdsource so much of our data that we used to kind of have to go out and be like, hey, can you share that with us? And then they're responsible for their own data, right? They're collecting it. Well, if there's an error, that was someone in your team. Yeah.
I would love to hear some of the details of how you created that valve thing where you could show all of the shut-off valves, which seems like a monumental.
So how do we collect them? They're actually collecting them. I mean, they're building it from the ground up. There was nothing. Actually, that's not true. There was a outside firm many years ago had gone out and done old, like literally a ring binder with static photos and a little description. And we added that into the one building to get them started, just so that they had something. But literally, when they went out with collector, they had that one building with the 3/4 of valves, and now they're roaming around campus, going to each building and starting to populate that data set from the ground up. There's nothing to start with. Go ahead.
If you need some more info on that, I can get you.
Yeah, if you want more detailed on
how we actually developed the app. Yeah.
My hope is honestly is just with the new indoors that we wouldn't have had to custom code that, right? With the indoors will now allow, if you guys haven't gone to the Little Esri plug here, it has a nice little scrolly bar with the floors. Then that will be an out-of-the-box thing, so you won't have to program it like we did. Yeah, question.
How do you decide what kind of data goes into your GIS database versus your space management versus your Revit?
Yeah, so on as it comes to us. I mean, we kind of have a discussion, and we think through, before we decide, right? We think through, how is this data going to be used? Who is going to be the owner of the data? Who's going to be responsible for maintaining it? And honestly, up until now, that has always seemed to answer our question of where should be the logical home for that. Sometimes that you're not sure, like valves, so sure, we could keep them in Revit. But the ease of use and the who's going to be entering the data, the people entering those valves are not working in Revit, right? So it seems like for each of the data sets that has become a question, it kind of answers itself as we reason through who's using it, how is it going to be used, how are we going to continue to maintain it? Yeah.
How are you managing your logins? Are you using Portal or are you using Federated?
Yeah, our Shibboleth Authentication is what we're using for our login. And then also we use that for our ArcGIS Online account. We've used that enterprise login through Shibboleth for that as well. Right now, ArcGIS Online, we are moving to Portal. We hope to not, honestly, because then that forces us to administer both a GOL and Portal. Not to start rumors, but I hear with the next version of Portal that it won't, some of the restrictions that force you to use Portal won't be there, right? You'll be able to publish straight out of Pro into 3D. Some of those extensions will be available that are really only available if you're using Portal right now. So we'll see how that goes.
Sorry to follow up. How
Yep.
are you handling the number of users you have to have for an ArcGIS Online account?
That has not been a problem for us yet. I mean, obviously, right now we have 2 AGUL accounts. We have both the academic side and our administrative side. It hasn't been a problem. I mean, and Esri's told us they'll continue to add users as we need. Well, we haven't hit that threshold yet. I think we have over with potential 1,000 right now. I don't see us needing 1,000 staff that are really going to be doing true data editing or data publishing. Yeah, go, Jeremy.
For the group, Shibboleth is our university-wide
Yep.
network login. It's managed by
It's a SAML. Yeah, it's a SAML. Sorry.
University's IT department, and we plug into it.
Right.
Right. I mean.
Yeah.
So it's a centralized clearinghouse for everybody's network login. No matter who's runs through it, which takes a lot of the load off of you managing.
Right, we don't have to manage that,
have
right? It's the enterprise login, right? Esri calls it the enterprise login. You could hook to SHIB like we do, or any other SAML system that your university might be using.
So then for the external, you're using then guest accounts?
Yeah, guest sponsors accounts. So yes, they absolutely have to have a name number, or they can't get to our systems.
There are project management people are already in, but any consultant that comes on, right? So they award the project and they get in. Well, one of the lengthy things you've got to do to get started is get them a guest account.
Yeah.
Lets us go back to the people that sponsored it and say, hey, what's your guy doing?
Yeah, you'd think it would be like cumbersome, but it's not. It's not that bad actually. You know, Joe, like we don't get that many requests, and when we do, a lot of the outside users tend to end up being the same outside users year after year after year. That's just generally what we. Yeah.
Great information. I appreciate it. So I'm curious about the trend of this indoor mapping. So there's a huge need for wayfinding inside buildings. Do you see your policy changing then about how those plans
Yes,
are shared?
that will be interesting.
Yeah.
Yet to be
Where
determined.
you are.
Yet to be determined. I think the intent absolutely is to be able to have, you know, it publicly available. I think what that will end up meaning is that some of the buildings may be grayed out. I mean, even for the people that have access, there are a few buildings that are just not really there for anyone to see. So, but absolutely, right? We're right now in that process because we are already pulling our Revit and our 2D DWGs in or showing our floor plans, and we're in the process of building our network because, you know, we can already navigate across sidewalks, and right now the buildings are kind of black holes that we'd like to fill in. Go ahead.
I'd just like to follow up on that. Security of information is handled through our central IT department. And we have a 5-scale level of security for information from credit cards, and floor plans are included in there. I think level 2 security plans. We have level 1, which is public, and we just wrote a level 1 definition for how you make the floor plans available to the public. Because basically, if you make it available to students, you made it available to the public. And maybe if you have a copy of FaceTime for CFDA, we'd be happy to put it there.
That would be great. Please do that. And in case the recording didn't hear, he said they already have kind of how to modify your floor plan standards, and that would be great because that will be something that we're going to have to be doing here in the near term. Yeah. Go for it.
So how we've handled it is we've gone to another level of floor plans.
Right.
Where there's a publicly available set that has all the mechanical rooms, the animal labs, the offices that are restricted, they're all blacked out. And only the rooms that we want people to be able to go to, like classroom to classroom, is what's available on the public side.
Right. Yeah, go ahead. Question.
You mentioned standards, that's great.
Yeah.
I'm wondering what level of compliance you have with those.
Yeah.
Good, how do you manage
It's a struggle. Yeah, you're right. We still don't get as-built sometimes. We do the best we can. We send reminder emails. Rajni knows all about standards and drawings not coming into proper standards. I mean, we do the best we can within reason. There is no good solution to that other than being like, at least you have standards, and if they're not compliant, you send it back a couple times, and then if legal gets involved, sometimes that doesn't even really resolve it. So, yeah.
Empowered and you have the standards police, I mean.
Yeah, we just send it back, right? Like if we get a,
A lot of emails back.
yeah, you just send it back.
DMs and they-
Yeah, send us something compliant. A lot of times you just include the standards. Please see standard. Like self-explanatory.
Yeah. Unfortunately, in Ohio, we don't have, and this varies by state,
Yeah.
we don't have a lot of leverage to force the as-bills.
No.
People, depending on where you're from, your state may have given you a lot bigger hammer to hit them over the head with. We've got a little soft,
Yeah.
squishy mallet. We can't force a lot here in Ohio.
Yeah, sometimes they choose to just walk away and not deliver. Like, they're like, that extra 10% is not worth it to us. We know it's going to cost us more than that to fix it, that, deliver you an as-built.
Which is kind of why we track our utilities outside the way we do, is because historically we haven't been able to get as-builts. The should-have-been builts don't work because everybody knows in the field they've changed stuff. And when you got to go back out and tell the guy that's digging that's where it's at, yeah, no, that doesn't sit well with our people. So that's why we track them, kind of live as they're going in.
Yeah, and just a big disclaimer on any of our GIS, it's for general reference only. It's to help you make a better decision, but please don't ever take anything we have as gospel, because it comes from so many disparate sources. I mean, some of it is literally just heads up digitized off an aerial photo. You can't, it's just to provide you a general idea of what's going on out there so that you don't have to go out in the field. If you're to the point of building, don't ever use our stuff. It's not what it's for.
Or ask us.
Yeah, or ask us, Lee.
I'll tell you what's good or bad.
For the record documents, I have been told by our shop guys, we'll have record documents on, like record documents, not as-bills, because I'm always asking for the record. So what that project completed on December from January to that's what you see. They'll go out in the field and even the record document that we provide does not match what's on the field. So you can't always rely on, even on the record document.
Yeah, we do the best we can. Go ahead.
Do you have something in place for internal enforcement? I mean, I think it's harder to get our project managers to give us that.
Sure. I mean, I think we all struggle with the same issue. I mean, OSU has now hired a person to specifically do that job. I wouldn't.
People send an email, myself and her, and it still isn't.
I was going to say, it still hasn't solved the problem. I am hopeful that our new system, right, like our project management system that's supposed to come on board, will kind of force that. They literally won't be able to move forward with the project, close out that project until I've clicked the box that they did their job, right? So, are we sure?
Got a couple minutes left.
So how do you track your utilities as they're going in?
As they're going in, well, because we are also the ones out there marking during construction, we've got 2 surveyors and, good survey equipment. And what ends up happening is, because they're required to provide as-builts, the smart contractors are like, wait a minute, you're taking shots on this, can we get that? Sure. And then you can hand it right back to us and get paid. And they're like, then the light bulb goes off, and then we start getting notified when they're putting stuff in. So you gotta have some field guys that work real good with the contractors, and it's worked out real good for us. The stuff we know exactly where it is, and we're confident. So.
Just have one more in the back.
Any other final question? Liz? No, you're good. Well, feel free to come and tag us after
Thanks,
if you want.
Marissa.
Yeah.
Thanks, everyone. Appreciate it.